especially, but focusing on biomass and environmental sustainability. And we know that there has been a lot of activity within the US government in the recent years to support the bioeconomy, from the executive order launched in 2022, the CHIPS and Science Act, the establishment of the National Security Commission on Emerging Biotechnology, investments from the Inflation Reduction Act. The list goes on. But what about environmental sustainability? We know that the US bioeconomy has an unparalleled potential towards achieving US climate change goals by incorporating environmental sustainability into its frameworks. And as the US government continues to create a strategy to enable this potential, it will be important to understand the relationship biomass has with achieving environmental sustainability in the bioeconomy. And so with that, we're going to dig pretty deep into that topic today. And starting off with a presentation about the 2023 Billion Ton Report from Dr. Matt Langholtz from Oak Ridge National Laboratory, followed by a panel discussion that I will moderate. If you have any questions today, you can put those into the Q&A button, and my colleague Nazish will moderate those and be able to give those to our panelists at the end of our discussion. But without further ado, I would like to introduce our panelists. First off, we have Dr. Matt Langholtz. Dr. Langholtz is a national resource economist in the bioenergy group at Oak Ridge National Laboratory. He's the PI of the Resource Analysis Project at Oak Ridge National Lab, and his research interests include biomass resource economics, short rotation woody crops, and bioenergy from forest resources. Welcome, Matt. We next up have Dr. Valerie Reed. Dr. Reed is the Director of Bioenergy of the Bioenergy Technologies Office within the Department of Energy. She oversees efforts to improve performance, lower costs, and accelerate market entry of bioenergy technologies. She has more than 30 years of experience in addressing energy and environmental issues faced by the United States and globally. And most recently, she is the lead for the Sustainable Aviation Grand Challenge team. Welcome, Valerie. Next up, we have Rick Fox. Rick currently serves as the Bioeconomy Coordinator in the USDA's Office of the Chief Economist. He returns to the USDA after a 5-year sojourn in the hemp industry, during which he co-founded Meristem Farms, a nonprofit that builds partnerships to fulfill the promise of hemp in the bioeconomy as a climate smart driver, I should say, of opportunity for all. Welcome, Rick. And last but not least, we have Tom Dower. Tom is the VP of Public Policy for LanzaTech and has nearly 30 years of experience in Washington, D.C. in government and industry, specializing in energy and climate policy. Prior to joining LanzaTech, he spent over 8 years at ArcelorMittal as a senior director of government relations. He previously served 15 plus years in the U.S. Senate for Senator Arlen Specter, including as deputy chief of staff and legislative director, and as senior climate advisor for Chairman Rockefeller on the Senate Committee of Commerce, Science, and Transportation. So thank you all to our panelists today for your participation in our webinar. And I'm going to turn it over to Dr. Langholtz for his presentation.
I will kick off here. Glad to give an overview of the 2023 Billion Ton Report on behalf of my 53 co-authors. So I'll start with the conclusion and then work back to how we got to this conclusion. So we currently use in the United States about 340 million tons of biomass per year for biofuels and biopower. And in this report, we look at future market scenarios, starting with the near-term market scenario. And in the report, we identify resources that we currently have, waste resources and byproducts that could add a production capacity to roughly double our current biomass production for energy and co-products. And then we look at a range of mature market scenarios with the addition of energy crops, and we identify a production capacity up to about 1.1 billion tons of biomass per year, or up to 1.5 billion tons of biomass per year in the high scenario. And this low, medium, and high, these are driven by yield assumptions, kind of conservative to more optimistic yields, tons per acre per year of energy crops and conventional crops. And then we have an emerging scenario on top of the mature market scenario, adding the microalgae and macroalgae resources that we could see in the future. So all in, the potential to roughly double, triple, or potentially quadruple our current biomass production capacity. And this is not all the biomass we have. This is a subset of the biomass production capacity within our specified environmental sustainability constraints. So background, of course, we have national goals for reducing greenhouse gas emissions. For example, we have the SAF Grand Challenge targeting production of 35 billion gallons per year of sustainable aviation fuels by 2050. And another way of looking at this, if we wanted to displace all of our hard to electrify sectors with sustainable biofuels, that would require about 70 billion gallons per year by 2050, which is roughly 1.3 billion tons of biomass per year, which is roughly the production capacity that we estimate in this report. So that's not the target of this report because we're end use agnostic, just an example end use demand. So that brings us to this report, the 2023 billion ton report, or BT23, fourth in a series of national DOE funded biomass resource assessments that are used to inform research, development, and deployment strategies around the bioeconomy. A main purpose of the BT23 update to latest economic conditions and inputs. Things have changed since 2016. Also in this report, we're trying to do a better job in terms of clarity by what we mean in terms of production capacity and our level of resource utilization. I'll try to convince you of that here in this presentation. Adding some new resources like shown here. Just emphasize, like always, we don't target 1 billion tons. We don't predict anything because we can't predict market trajectory. We're policy agnostic and end use agnostic. So this is not, these resources we identify, it's not particularly for any end use. It's just a resource assessment of biomass production capacity. So 54 contributors from 11 organizations and 30 reviewers from 17 organizations, as always, contributing to our billion-ton report. So in this report, we'll review resources that we currently use for bioenergy and co-products, and then go into biomass resources that we currently have and could use, and then the emerging resources that we could have in the future. So 7 classes of resources color-coded in the report. Each class was analyzed by a team of researchers building on years of work, often with biophysical models and in some cases economic models. So there's a lot in this. I'm just going to scratch the surface of this report. Starting with the currently used resources as the base of our production capacity. So we currently use about 340 million tons of waste, wood resources, and agricultural resources. This is largely wood waste to power and corn grain to ethanol, combined producing 5% of our total U.S. energy production. So biomass energy being the largest single source of renewable energy. So in this report, exploring if we can double or triple this to say 10 or 15%, for example, of our U.S. energy production capacity. So how can we grow this? Starting with waste resources currently available, not used. Waste resources across the country, diverse mix of resources shown here, wide range of prices. For example, the fats, oils, and greases are comparatively expensive, but of course, easier to convert. And just to emphasize this, 217 million tons per year in the mature market scenario, it's about half of our waste after we account for waste that is currently recycled and otherwise used. So next resource class in the report that we have currently are timberland resources, up to about 60 million tons per year. We have timberland resources coming from our working timberlands in different parts of the country. This is largely comprised of logging residues, about 19 million tons of logging residues, and small diameter trees, about 35 million tons of small diameter trees. Estimated prices from $40 to $70 per dry ton roadside before transportation. That's all these costs are reported. Again, the logging residues, it's not all of our logging residues. So every year from our forest conventional operations, we have about 40 million tons of logging residues produced, but within our environmental sustainability constraints, picking up less than half that. The small diameter trees, 35 million tons, just for context. That's about a 17% increase in what we currently harvest for our conventional wood products. It's less than 1% of our timberland growing stock, and combined its harvest less than net annual timberland growth. Next, the agricultural resources, a wide range of resources depending on the scenario, about 600 million tons per year in the mature market medium scenario. This is largely agricultural residues like corn stover in the Corn Belt and energy crops like switchgrass and willow outside the Corn Belt. At a reference price of $70 per ton in our mature market scenarios, that brings in the mature market medium scenario, that's about 600 million tons of cellulosic resources. But then we also include, for the first time in this report, the intermediate oilseed crops, 28 million tons of off-season or kind of winter cover crops like pennycress. Again, higher prices, but more convertible. A word on the corn stover and the wheat straw. It's not all of our corn stover and our wheat straw. It's about a third after our environmental sustainability constraints, right? The total is not much of a mystery. If we have 90 million acres of corn, about 5 tons of stover per acre, in this case, about 450 million tons per year of corn stover out there, we don't include all of it because of the environmental sustainability constraints. And the 400 million tons per year of energy crops, that's modeled on about 8% of cropland and about 11% of pasture land, while still leaving about 70 million acres of agricultural land idle, and while meeting projected demands for food, feed, fiber, and export. So how do we assess the production capacity of these energy crops? Word on that real fast. So some stakeholders are concerned that energy crops will displace food production. So we explore this risk in this report. So we can grow energy crops on non-agricultural land with no impact on food production. But a good faith question might ask, what will happen in a free market where farmers have the flexibility to decide where they grow energy crops? Farmers decide where they grow corn, where they grow soy, where they grow wheat based on comparative economic advantages of different crops in different places. So that's how we approach this question with energy crops, using a partial equilibrium model that solves for the most profitable mix of crops at the county level based on inputs like yield, costs, and then projected demands for conventional corn, soy, wheat, etc. And then we introduce demand for energy crops. And this is the result. Shown here is the result of our mature market medium scenario for the cellulosic energy crops. Of course, you notice there's a hole in the middle of our results. Of course, that's the Corn Belt region, the prime cropland, and we don't exclude this region from our analysis. We include it. Basically, we let the crops compete. We simulate a free market. We find that corn and soy have comparative economic advantage in prime cropland, and the energy crops like switchgrass and willow have comparative economic advantage outside of prime cropland. Still, a fair question is, what might be the impact of this added agricultural pressure of growing energy crops outside the Corn Belt? To go into that a little bit, looking at this in terms of, so here's a 30-year historic inflation-adjusted prices of soy, right, dollars per bushel. And then here's a model business as usual scenario with no energy crops. So this is just a future market equilibrium price. Of course, it won't be this smooth. It's just an estimate of market equilibrium price. And then we add the price impacts of our low, medium, and high energy crop scenarios. And we see less than a 5% or about a 5% increase in the soy commodity prices, but less than recent historic variability. So a non-zero but small price impact. Similar approach with wheat, about a 25% increase compared to the baseline, but still well within recent historic variability. In the case of corn, very little price impact due to interactions with profits from corn stover. But so focusing on the last year of these scenarios, 2041, that's our mature market year that we report in the mature market scenarios. In terms of grain production, corn, soy, and wheat, food price impacts and market revenues, in terms of a just index to a business as usual scenario. And then we add the low, medium, and high energy crop scenarios, which produce 300, 400, or 600 million tons per year. And just to emphasize, these scenarios are driven by yield. So this is the low, medium, and high yield scenarios. You could think 8, 9, and 11 tons per acre per year, though it varies by energy crop and by county. So in the mature market low scenario, major grain production is down 3%. Food prices are up 0.7%. That's less than 1%. And farm revenues are up 25%. Okay, so for reference, this 3% drop in production, for comparison, is about half the annual variability in corn, soy, and wheat production over the past decade. So for example, US corn production was down about 10% in 2022, and then up about 10% in 2023. So this is a small impact. In the mature market high scenario with the optimistic yields, there's virtually no change in grain production, no change in food price, and market revenues increase about 30%. If we can achieve the yields of the high yield scenario, then we can also produce the 300 or the 400 or the 600 million tons per year of energy crops with near zero impact on grain production or grain price, while still achieving big improvements in farm revenues. So just to acknowledge, this is a difficult topic to cover in a short overview, but our thinking is that we do everyone a disservice if we avoid this topic or if we oversimplify this topic. So in the BT23, we've pulled these impacts out of the appendix and put them in the executive summary, and they're also in the ag chapter and the sustainability chapter. So next, we'll look at what drives these increases in farm market revenues. Compared to the business as usual scenario, farm revenues are up about $20 billion per year in the mature market low, medium, and high scenarios due to a combination of the higher crop prices, returns from ag residues, and returns from energy crops. And farmers across the United States have the potential to benefit from improved incomes. In the news earlier this year, as we sometimes see, there are concerns about the economic sustainability of farming, and energy crops and biomass markets can improve the economic sustainability and environmental sustainability of farming in the US and elsewhere. Okay, so how optimistic is this resource assessment? So we've used this figure in the past to illustrate that we're reporting biomass production capacity constrained by biomass prices and within our modeled environmental sustainability constraints. And the total resource base is greater than the production capacity that we report. So I'll try to discuss this aspect quantitatively from this report. So for example, the mature market medium scenario has an annual production capacity of 1.2 billion tons of biomass per year, of which about a third is currently used under current market conditions, and with increased market pull, we can produce more and use more. So the first point is we don't report the total. We report the subset within our sustainability fractions and other constraints. So for example, waste resources, like I emphasized, there's much more out there, but the fraction that's unused is 217 million tons per year. Maybe waste is the low-hanging fruit. Maybe the low-hanging fruit has already been picked. Remains to be seen. Logging residues, kind of similar situation. Logging residues is a relatively small part of the 1.2 billion ton total. 19 million tons per year. There's about twice that out there every year, produced every year. Within our constraints, we pick up 19 million tons. The small diameter trees, 35 million tons per year. This is the amount that we model as being available on an annual basis in perpetuity at $70 per ton. The wildfire crisis strategy needs to treat 50 million acres over the next 10 years, and there's feedback from the Forest Service that, of course, there's a lot more out there, and there is. And that could be a bridge to the bioeconomy developing in the future. This is just the amount. This is deemed a conservative estimate of what's available on an annual basis in perpetuity. And the agricultural residues like corn stover, There's about 500 million tons out there, but within our sustainability constraints, we get about a third of that. There are questions about short stature corn. We don't know if that means there's going to be less stover or if it's the same amount of stover, just recomposed in a different size plant, or if it means higher yields, then that makes production of energy crops easier. So some unknowns in certainly all of these categories. The energy crop potential, like I mentioned, the main dial here, the main variable is yield. If yields are high, this is deemed, we believe this is quite achievable. If yields don't improve, it would be more difficult to achieve this. Maybe we're optimistic in terms of adoption and market penetration, or maybe when we put a value on the ecosystem services like soil organic carbon and improved water quality that could be achieved with deep-rooted perennial biomass crops, and we deploy these energy crops on the landscape using a strategy like integrated landscape management, where we put energy crops where they have comparative economic and environmental advantage, maybe this is achievable. So it remains to be seen. So maybe the main point is we're not reporting the total, we're reporting a subset of the total. And another important point is we don't imply precision at any level. Rather, we aim for an accurate assessment overall. So there's uncertainty that could be explored in each of these resource classes. And finally, this is not an exhaustive assessment. So this doesn't include storm debris, beetle kill, herbaceous cover crops, production from reclaimed mine lands. This is not intended to be an aggressive assessment, rather an assessment within existing biomass producing industries. Okay, quick word on sustainability. Hard to measure, but it's the main goal of the bioeconomy. So some billion-ton history. The 2016 billion-ton report included a volume 2 titled Environmental Sustainability Effects of Select Scenarios from volume 1. And in that analysis, we modeled impacts of BT16 scenarios on 13 environmental sustainability indicators within 5 sustainability indicator categories: soil quality, water quality and quantity, greenhouse gases, biodiversity, and air quality. So this involved 60 authors from 15 organizations. And the upshot from this volume 2 is that there is potential for a substantial increase in biomass production with minimal or negligible environmental effects under the biomass supply constraints assumed in the BT16. However, a concern from the EPA review at that time was that we constrained the billion-ton analysis to be sustainable, and that future practices could deviate from those constraints. In the BT16, our modeling, again, includes nearly 20 environmental sustainability constraints on agricultural land and timberland, things like residue retention coefficients, irrigation exclusion, excluding sensitive lands, and other constraints that are provided in Chapter 1 of the BT23. But again, a concern from the EPA review is that future production practices could deviate from our assumed sustainability constraints. So an output of the EPA review of the BT23 is Chapter 6, shown here, Sustainability and Good Practices. So Chapter 6 explores the risk of future practices deviating from our assumed sustainability constraints. For example, when we relax constraints on the agricultural residues, ag residue production can roughly double from 200 million tons to 400 million tons per year. So there's potential risk of over-harvesting. The impact of relaxing constraints on the logging residues is small. Production increases from about 20 million tons to 30 million tons per year. And relaxing constraints on the small diameter trees is minimal because the production is limited by price. So it just depends on the resource. So in some cases, for example, in the case of the agricultural residues, some guardrails could be needed to avoid deviating from our sustainability constraints. Best management practices, monitoring, etc. In the case of the energy crops, there are some concerns of indirect land use change, food versus fuel, and these issues are also discussed in Chapter 6. And energy crops could be a driver of land use change. But land tenure issues, government policies, agricultural subsidies, infrastructure development, and other local social, political, and economic factors are also identified as important drivers of land use change. So in Chapter 6, we try to be clear about what we know and what we don't know, and about the sustainability constraints and indirect land use change factors in the report. Emerging resources, up to about 250 million tons per year of the microalgae and macroalgae at higher prices. Maybe technological innovations in the future could bring these prices down. And also carbon dioxide, which could be part of a decarbonization strategy. We identify 3 billion tons per year from stationary sources, of which about 50 million tons per year comes from high purity sources, which could be accessible at lower prices. Of course, different resources are available at different prices. And this is the supply curve. More is better and cheaper is better, all else equal, starting with resources that we have today. Adding energy crops in the low, medium, and high mature market scenarios, and the emerging resources, and just showing a range of different resources at different prices, with different resources having different comparative economic advantages for different decarbonization pathways. So to roll this back up, about 340 million tons of biomass per year currently used. We look at future market scenarios, starting with what we have today, and we can roughly double that to about 0.7 billion tons of biomass per year. And we look at a range of mature market scenarios where we can roughly triple or more than quadruple our current production capacity in the future. And this is not, again, not all the biomass we have. It's within our environmental sustainability constraints. And for reference, if we want to produce 35 billion gallons per year of sustainable aviation fuels, requiring about 600 million tons per year of biomass, one could see that sort of demand being satisfied from a range of these different resource analysis classes, with room for addressing other decarbonization strategies. So overall, a diverse portfolio of resources across the country, with each region poised to contribute to grow the bioeconomy. And we have a new data portal on the Knowledge Discovery Framework, or KDF. And we invite users to explore our data portal and use our data. And please reach out for anything. There's more data than what's available on here. Just to acknowledge, that was quite a rush. It's a big report. Thank you for the opportunity. Yeah.
Thank you so much, Matt. I mean, yeah, I think the two big summary points here is that we have a lot of biomass in the US, and this is a really big report. And so if you haven't already taken the time to dig through it, I would really recommend it. There is so much good material in there, and I'm really happy to have you level set our conversation, Matt. Thank you.
Thank you.
So we're going to go ahead and dive right into the panel questions now. So I invite our panelists to put your videos back on. I promise we'll talk more. So awesome. Our very first question is going to be for you, Valerie. And just to kind of bring us to the bioeconomy first, what does bioeconomy mean for you or for your agency? And how does biomass fit into that definition? And you're on mute.
Sorry about that.
Oh, good.
Bioeconomy is a very big term. It really does reflect on many aspects of our economy, whether it's pharmaceuticals or industrial uses. But let's talk specifically about where DOE is focused, and the Bioenergy Technologies Office, and that is in the industrial bioeconomy space, which we define as transportation fuels and chemicals or materials, okay? So overall, we recognize that petroleum needs to be replaced with a more sustainable resource. And from that, we get many of our useful products today, whether it's plastics or other chemicals that are used across our entire economy. And so by looking at where we can make biomass work, it is in the displacement of that petroleum. Now, Matt mentioned, and others here are interested in the sustainable aviation fuel production. And as DOE evaluated the options for biomass, we looked at those places where there were no other renewable technology alternatives. And that's where hard to electrify modes of transportation became obvious, and aviation being the largest of those. So Matt did an excellent job of showing the potential for us to hit our goals and to really make a mark in the aviation industry when it comes to sustainable aviation fuel and decarbonization. But it doesn't end there, because we also can have a role to play anywhere renewable diesel is going to be of interest in the market. So that is our broad focus when it comes to fuels. And then there's the hydrocarbon chemicals that I mentioned that go into polymers and plastics, incredibly important part of our overall economy for a whole lot of good reasons, and also impossible to find alternatives for.
Yeah.
So for us, biomass plays a role in those areas.
Yeah, thank you so much. So Rick, I'll turn it over to you. How is USDA defining the bioeconomy, and where does biomass fit into your definition for that agency?
Sure. So we've gravitated towards the definition that the Congressional Research Service came up with, which isn't really much different from what Valerie said and probably what you'll hear from others. Basically, it's the bioeconomy includes the share of the economy based on products, services, and processes derived from biological resources, and encompasses multiple sectors: ag, textiles, chemicals, and energy. So added to that, we take a focus again that's reflects something that Valerie just said, is with the goal of substituting renewable resources for non-renewable, essentially substituting for fossil fuels, petrochemicals, things like that. So through that lens, that's the lens we look through at USDA to sort of put some edges around the bioeconomy space. And USDA has been producing biomass and other biological products and services since 1862. So we kind of can say we've been serving America's bioeconomy since 1862. That's when we were established. Which that's a little bit of an exaggeration, but it's not that much, because pretty much every missionary within USDA has a touch point on these biological products that substitute for non-renewable resources. So and from our perspective, again, and I don't think it differs from what others view on it either, biomass is the foundation of bioeconomy. We're talking, and it can be plant-based or animal-based, but what we're working with is stuff that we have to grow or raise on the most part. And so, for us, our major focus, as you heard in Matt's presentation, biomass, we have in abundance, particularly in the form of hazardous fuels and harvest residues and mill wastes. So, we are very keen, all of us in the interagency, very keen on finding ways to get those fuels and materials out of the woods or out of a log yard and into something useful. Not only for reducing wildfire risk and creating economic opportunity, but also that increases the value of wood and hazardous fuels, which ultimately reduces the cost of these kind of treatments. If there could be some value recouped, then loggers we'll go fetch more of it out of the woods, and because then they know they get a whole range of things like that. So but woody biomass isn't the only one. We are looking at a lot of emerging feedstocks, Waiuli and domestic natural rubber, lignin cellulosic crops like switchgrass that Matt mentioned. You mentioned hemp in my bio. Hemp fiber is on the radar there, although it's very, very small relative to other things. And lipid crops. I think Matt mentioned winter oilseed cover crops. So these are the areas that we're focused on. I think maybe we'll get more into the relationship with biotech in a minute, but that's pretty much the lens that we look at it through.
Yeah, absolutely. And I mean, you touched a lot on that, but I want to, switch to Tom. How is LanzaTech looking at the bioeconomy? Do you see, big differences in how you're defining the bioeconomy and where biomass fits into that? Or is it pretty much on the same line?
Yeah, so let me maybe first explain to the audience who LanzaTech is, maybe less obvious than USDA or DOE. So we're and also just thank you for hosting this conversation, because I do think it is really important that various stakeholders be able to engage on this topic, because it is really an exciting time to be working on all these issues, which everybody here can attest to. So LanzaTech, just very quickly, is a US-based company. We're a carbon recycling company. with a strong emphasis on science, synthetic biology, research and development. We have over 1,450 patents, that are really at that intersection of synthetic biology, engineering, artificial intelligence, machine learning, and industrial scale biotechnology. Sort of to Rick's point, I'm sort of transitioning there already. But for us, we have a keen focus on above ground waste, carbon, and clean energy. Okay, so when I'm looking at Matt's slides, I'm really looking at all those waste opportunities. That there's a lot of energy and carbon available in waste biomass that could be used. And as a company, we use a technology process we call biorecycling. So LanzaTech captures and processes multiple forms of waste carbon before they can enter the atmosphere and cause harm. Emissions sources like steel mills and landfill sites can attach LanzaTech bioreactors to their facilities, which then act similar to a brewery, but instead of using yeast to convert sugar into alcohol, our proprietary microbes are converting carbon-rich gases into essential raw materials like ethanol, which is a primary ingredient in fuels and a range of everyday consumer goods that Valerie was talking about, really from fabrics and packaging to sustainable aviation fuel. So this process allows us to create value from waste. So for us, when we think about the bioeconomy, we really think of that as describing the value proposition our technologies can bring to society. And so with biology at the center of our process, we're able to create value from waste, including waste biomass resources. And that translates into helping to decarbonize, or more accurately, defossilize several hard to abate sectors simultaneously. In our case, one example is capturing steel mill emissions and transforming them into SAF, sustainable aviation fuel, or carbon smart chemicals that go then down the product chain that Valerie was talking about. So biomass can be a really important part of this equation, providing essential feedstocks that importantly will always be available as long as humans grow food and other crops.
Yep. I mean, period. Like, one of the things I really think I want, everyone to take away from this webinar is that, biotechnology, biomass could be a key driver to helping, defossilize all of these household items, but also help the public understand that biotechnology is an amazing tool for that. And it's not just really niche scientific topics, it's everyday uses. And so, Valerie, I'm going to direct this question to you in one sentence. So the executive order in 2022 and NIST defined the bioeconomy largely in the terms of biotechnology and biomanufacturing. Do you feel like this is an adequate definition? In one sentence answer.
Not all the products we envision coming from biomass will come through a biological processing. If you attach the biology to the biomass, then yes, indeed, it is adequate. But we know that there are many technologies that we're going to need for the diversity of biomass that will result in these same products. So for us, it's much larger than just what's in those definitions.
Yeah. And Rick, I'll point the same question for you here. Do you feel like the NIST definition of the bioeconomy is adequate right now?
If we take a very broad view of the terminology they use, when they mention something along the lines of derived from life sciences, it is adequate, but you have to take that broad view of what it means. And so what I really think is more what Valerie is saying, that it is not, because so much of the bioeconomy it is not necessarily, there can be, thermochemical or mechanical processes for producing products from the bioeconomy that substitute for non-renewable resources. And also, the narrow focus, making this a rather long sentence, but I'm almost done. The specific focus on biotech and biomanufacturing, might leave aside a lot of the potential the bioeconomy has for supporting rural economies.
Yep.
Sure, we want those high-paying jobs with biotech going out to the rural communities, but the lower-hanging fruit is the stuff that we already know how to do, but maybe don't do enough. That creates jobs. So there were a few semicolons in that sentence, sorry. But,
I won't edit that right here, right now. But I mean, I think you point out a key piece of the bioeconomy here, and I think to the BEA report on how do we measure the bioeconomy and that graphic Venn diagram of the bioecology portion of this whole spiel of, how are we regenerating resources, but also protecting the environment. And so kind of my next question here, according to the Billion Ton report, we have the ability to sustainably produce biomass needed to meet future energy needs. But what are the limitations you see keeping us from achieving this goal? And Matt, I'll direct that question to you first.
I mean, if it was easier than what we were already doing, we'd already be doing it. So certainly a variety of challenges on logistics and market pull and the right market signals to achieve the technological innovations to unlock the resource, right?
Yeah. Well, and on that point about technological innovations, Tom, at LanzaTech, what are you kind of seeing as another maybe infrastructural piece to a challenge that we're seeing right now?
Yeah, well, actually, I think a lot of what Matt just said is really important. It's really aligning policy, markets, supply chains, incentives, particularly for us. I mean, we are a very climate-focused company. Okay, so we could talk about how biotech could be applied to so many things, but we are heavily focused on almost exclusively climate through the lens of also, by the way, making sure we don't have the other consequences for environmental sustainability, environmental justice, all of these really crucial issues that will stop everything from happening if we don't get it right. But what we constantly remind policymakers and stakeholders is that we should be very careful about being too prescriptive about definitions. Sort of, going to your last question, what government is always lagging innovation, right? So we take a very tech neutral, performance-based approach in policy. That's what we are seeking, and therefore, once we have alignment of policy, then to your infrastructure question, it becomes a matter of what will incentivize the right kind of deployment to get to the most highest best use of resources, and if that we could use SAF or aviation as an example. That's about building actual production of sustainable aviation fuel and sourcing that sustainably all around the United States, all around the world, to meet that sector's really hard to abate needs. And doing that would include helping with CapEx funding, with financing. Various companies and technologies need different kinds of help depending on where they are on the TRL curve, and getting over the valley of death between their technology being a great idea and demonstrated, but truly at commercial scale and deployable beyond the nth plant. That takes a whole suite of policies.
Yeah, I mean, there will be future questions on this, but completely agree. Valerie or Vic, do you have any thoughts on what limitations you see that are keeping us from achieving some of those future energy goals with our biomass use?
Well, I will add, Matt mentioned market pull. I've been doing this for 30 years, and I go back to the original Billion Ton. And over the years, we've seen different policies where the U.S. values a piece of this puzzle. But because of shifting policy, we see also those markets come and go. A good example of that is the growth of corn ethanol. We were able to see the growth of corn ethanol simply because of the banning of MTBE, really, and the need for an oxygenate that could only be met by corn ethanol, which was available to us at the time. And we went from a very small amount to over 210 biorefineries producing 16, 17 billion gallons. That is the type of pull that we need for this industry and for us to really realize this. And we're seeing it today in things like aviation and driven by decarbonization. So I think that we are starting to see a real change in market pull for these technologies, but it's going to require us to focus in on cost, reliability of sustainable issues, and also this transition from an oil-based economy to one that's biomass-based, and ensuring that we're doing it in a fair and equitable fashion.
Yeah.
So, I mean, those are very broad barriers that we are all facing, but those are
Yeah.
the things that we need to focus on.
Yeah. Any points on that, Rick?
Sure, and my internet might have cut out and back, so
Right here.
but great. I just briefly, in addition to all the challenges that Tom and Valerie mentioned, look, we've been trying to come up with definitions and criteria and targets for sustainability for decades. And the struggle continues, and it's a good struggle because there are different points of view as what is, what constitutes sustainable and what's not.
Yeah.
I think the challenge and the opportunity we have right now in biomass is that there's a lot of energy focused on the measurements, life cycle analysis. So, really the criterion indicators so that we're all counting the same things is important. But then, how much of something is enough? It depends on the jurisdiction. It depends on some politics. I mean, we all have our own opinions, and I think there's legitimate desire to see some global agreement on targets, obviously in climate, but biodiversity as well, and environmental justice. So I think if we can start by measuring the same things and reporting transparently and accurately, how our various bioeconomy products and methods measure up, then there can be the debate about how much is enough. So
Yeah.
that's even the measuring is much harder said than done. I mean, carbon intensity of biofuels, of course, everyone here on my fellow panelists know more about that than I do, but it's something that we talk about. And then in forestry, there's for decades there's been debate about when to start counting in terms of the sequestration of carbon in wood. But if we can get the measurement right, then we can have informed and transparent discussions about what sustainability actually is. So that's how I see the challenge.
And that point, especially about, how are we measuring sustainability and kind of the nebulous term of what sustainability actually means, because again, like the bioeconomy, that could mean 3 different things depending on what lens you're wearing at that point in time. And so, Valerie, you kind of mentioned corn and how that's largely being processed into bioethanol, et cetera. And so my question to the group here, and maybe we'll start with Tom, is the biomass we're currently using environmentally sustainable? And what are the ways that you see, or challenges, I should say, in determining what sustainability looks like when we are kind of using that biomass? Life cycle analyses are tricky. Carbon intensity can vary depending on what your supply chain looks like. So I'd love for you to comment on that.
Yeah, wow, that's not a softball.
No.
So I guess at a high level first, let me start. I think few things that humans do are truly environmentally sustainable, but some people who are closest to that question are those who are closest to nature and closest to the earth, right? So it's harder for me to think about people that are closer to the earth than farmers, ranchers, forest stewards, people who are there every day. They can and year in, year out, and generations in and out, right? And can tell you exactly what day the first planting was 72 years ago. So I think what we all need is a deeper understanding of where things in our lives come from, environmental metrics and data around the impacts of producing those things, and market and policy incentives that are aligned with what is best for both economic growth and the environment. And I believe growth and sustainability can and should be linked in a virtuous cycle. And you could think of limitless examples, but I mean one thing that sitting in Washington D.C., big concerns about budget deficits and healthcare expenditures being a grave threat to developed economies, and reducing disease-causing air and water pollution, for example, reduces costly medical interventions, which improves productivity and worker longevity, and the health and wellness of whole communities and cohorts of the population. We should be thinking about all of these things holistically. And I think everybody on this call does that. Lots of folks in government, lots of folks in industry think about those things, and working together with all stakeholders to make sure we are really thinking about all of these issues holistically, because we often get stovepiped, and we solely focus on the life cycle analysis for greenhouse gas emissions, but maybe we ignore water use or energy use or parasitic load or those sorts of things. And you really have to think about all of them. And I think Matt did a great job of explaining how in the billion ton study, those are exactly the kinds of things that they're thinking about, which then get to the real world deployment and whether it can happen. So it's a huge challenge, but for us, it is the existential challenge of humanity today, is environmental sustainability. We are not going to have a planet that can support the kind of human life we have today going forward for future generations if we don't get a handle on this.
Yeah, absolutely. Valerie, did you have a point on that?
Well, I'm going to start very quickly with something I hear a lot lately, and that is, do not let perfection be the enemy of the good. So yes, I believe that we're headed in the right direction. I believe biomass is a lot more sustainable than petroleum, what we're trying to displace. So starting with those statements, I think we're headed in the right direction with the way we're measuring sustainability. And Matt did a great job of describing that. And we're not, as he said, we're not taking it all. But we need to keep doing more, and the science needs to get better. And new terms also that have been popping up to all of us are climate smart agriculture, regenerative agriculture, carbon capture sequestration, right? All of these things are innovations that we are now able to deploy that we were not doing 10, 15 years ago. And we need to learn more and to get smarter. DOE working with FAA, we meet with the NGOs on a quarterly basis, and we have learned from them where their concerns are. And we're turning that into our scientific investigations, things that we're doing and funding through the labs and with companies. We put out a funding opportunity for regional resource hubs that are going to do exactly this for energy crops. One of the questions in the chat asked about disruption of marginal lands, and I don't have an answer to that. But what I will say is that we're going to learn as we develop these field trials for energy crops over a long period of time. What does it mean to have deep roots for carbon sequestration? And yes, what does it mean to initialize planting in land that was previously unutilized? So this is data that we're going to collect, and we're going to continue to make our measures of sustainability more accurate scientifically. And many of you may be aware, the GREET model was recently updated for sustainable aviation fuel. It was released yesterday. That model indicates a new direction in sustainability criteria. Carbon capture, renewable electricity, renewable natural gas, and climate smart agriculture are all bundled into where the 40B tax incentive is going. So again, I think we're headed in the right direction.
Yeah, I would agree with that. Matt or Rick, do you have any last points on how we see biomass as environmentally sustainable?
They nailed it.
Yeah. Awesome.
Well, yeah, the only additional points I would offer are resilience and circularity. So, and resilience, there are some rather philosophical definitions of what resilience is, but in basic English, I think a lot of folks understand that. And it's quite similar to sustainability in the sense you're managing things so that various options remain on the table for now and for future generations. And so,
Yep.
I think as we look at biomass sources and also biomass supply chains, we want them to be able to react to shifting environmental conditions, shifting environmental needs, and also shifting economics, as we learned in the pandemic. So tied in with that is circularity. Generally speaking, circularity contributes to resilience. Again, for some rather, sort of theoretical, philosophical reasons. But it's also, it's sort of intrinsically, quote unquote, more sustainable because you're moving things around less. So, And so, and the one last thing is, you know, while soil carbon and sequestration in soil and emissions offsets are super, super important, let's not forget counting the carbon that we sequester in durable goods. And that's where another aspect where the bioeconomy has strengths when you're looking at, you know, sourcing building materials from bioeconomy products or more sustainable packaging. You know, that can hold carbon for a while too.
Yeah.
Lots of.
I mean, there's so many good things spinning around here. And I like that you brought in the circularity component, because I think based on what we've seen from Matt's presentation, we have a lot of waste in our kind of biomass toolkit. And I think maybe it just needs the appropriate technologies, infrastructure, push to maybe start utilizing those a little bit more. But kind of the last question, or second to last question, I should say, for you all. What is the role of biomass in reducing carbon emissions and reducing greenhouse gases? One of the things that we've consistently seen is the difference between biogenic and fossil fuel biomass, or fossil fuel carbon in this case. And Tom, you specifically brought up defossilizing versus decarbonization. So I might start here with you, and you know, what is the role biomass can play in sort of reducing carbon emissions and greenhouse gas?
Sure, and the rest of the panel is probably more qualified to talk about biomass itself, because we are more interested in the waste from biomass. But you know, I think as outlined before, as long as there are sustainability metrics that we are measuring the overall impact and using life cycle assessment as the accounting tool it is meant to be, to really account for what is happening to carbon, how much of it is being pulled from the atmosphere in this case, and then going into products, and to Rick's point, you know, what's the end state of those products? You know, some of those are long-lived products that will actually sequester carbon for a long period of time, or for some period of time, versus fuels. But you can go negative with biomass, right? So and then for us, there's another element, and we haven't talked much about it, but Matt certainly highlighted it on at least one of his slides, and that is, you know, when we use some of these processes that utilize biomass, there are also carbon dioxide emissions. And what, you know, talk about circular economy. One of my favorite examples of something we could do if we can deploy our technology in the right ways is take, there's a lot of CO2, you know, about a third of what ethanol producers are getting out the carbon out of their product. They're getting a third of it as CO2. We could capture that CO2 on site, convert it through gas fermentation with clean hydrogen back into ethanol, which is exactly what they're making already. And we just actually had this great Department of Energy conditional award from the Office of Clean Energy Demonstrations, $200 million to convert ethylene related production of CO2 back into ethylene, so you don't have to go get more oil out of the ground. To Valerie's point multiple times, this is really about comparing to the status quo and the paradigm we're in, which is an extractive, linear, fossil fuel-based economy, and we need to get to a circular economy. And biomass obviously already plays a role in that. And I think particularly with increasing yields and with these great technologies that many of us have, so many companies working on really exciting stuff, it can play a much bigger role in the future.
Yeah, absolutely. Matt or Valerie, do you have any points on, what role biomass could be playing in reducing carbon emissions, or kind of that greenhouse gas reduction?
Well, I'm gonna just give an example of when we look at the full life cycle of production of one of our products. 50% of the greenhouse gas emissions from a feedstock, whether it's petroleum or whether it's biomass, comes from the feedstock. So 50% of the overall greenhouse gas emissions attributed to a given product, let's just say ethanol, comes from the feedstock. So with the use of biomass and the circularity, where we grow biomass that absorbs some of those emissions, we can bring the overall carbon emissions profile down from where it is with petroleum, where that is released million-year-old carbon, and there is not enough plant life on this planet to suck it up, to only releasing very young carbon, and then using it to drive the production of additional biomass resources. So that's what I'd like to add.
Yeah, thank you. Rick, do you have any thoughts on this?
Just reinforce what Valerie said about plants. You know, I'm a forester by training, and my favorite form of carbon sequestration is photosynthesis. So yeah, and yeah, let's keep that ancient carbon in the ground.
Love it.
And you know, play with the house's money, so to speak.
Yep. Awesome. So as we kind of wrap up here, the last question I have for you all is, we've talked a lot about the challenges of biomass today. And really what we want to think more on is, what do you think would be needed to overcome some of these challenges? Is that technology development to process diverse biomass crops, not just corn? Is it infrastructure for biorefineries? Is it standards and definitions for sustainability? I think we've talked a lot about that. Or is it communications and addressing misconceptions to the public? Is it a little bit of everything? So Valerie, you unmuted, so I'm going to let you start.
I was going to say, you
dig in.
actually hit on everything. It is all of the above. And I would wrap that up into, we need resilience and continuation of effort. We cannot let shifting policies or winds change the direction that we're on, as long as we can justify it scientifically, which is what we work very hard to do, and continue moving forward. It's been 30 years now, and we have not gotten there yet. And I think we really need to prove these technologies are viable, not just environmentally. We spend a lot of time on environment here, but they make sense economically. They make sense at the regional economic level, and can really touch the lives of every American because of that. And so we need to use those drivers to keep moving forward.
Absolutely. I'll pass it over to Tom and then Rick, and we'll wrap up with Matt.
Okay, just really quickly on how to overcome those challenges. I think part of it is really updating information for all of us. More education on all of these issues and the things that people care about, including the issues that Valerie noted that NGOs raise, like really understanding them, really actually having a conversation instead of talking past one another, whether that's industry, government, or other stakeholders, and improving our mindsets and being, something that my CEO, Dr. Jennifer Holmgren, has been talking about is seeking more allies and getting more people to yes. It is so easy for people to say no, and sort of back to the perfect being the enemy of the good. Yeah, we all have opinions, but if we could move the ball forward, and for us that means we need market pull, we need technology support, we need tech neutral policies, we need finance, we need to support deployment of new technologies, even if they're not perfect yet, because no technology is ever perfect on day one. And the oil and gas industry has had about 150 years to spend, and trillions of dollars of public and private investment to get to where they are. If we're going to replace that with a circular supply chain, we really need to get started and not wait until we think we can pull a technology off the shelf, 10, 15, 20 years from now. Because, by the way, we don't have that kind of time. So we really need to transition these supply chains and get started right now.
Yeah, absolutely. I'll pass it over to you, Rick.
Everything everybody said so far.
Underline. Awesome.
Risking is so important. That's what enables producers to try new things, whether it's climate smart practices in agriculture or producing different commodities. It enables investors and banks to step in and finance. And these are very nuts and bolts kinds of things that DOE and USDA do a lot of already. Loan guarantees, crop insurance. USDA's Climate Smart Commodities program is built on the notion of de-risking farmers. So that's the big piece, I think. In addition to what Valerie and Tom were both saying about sort of maintaining some good communication and stability through shifting winds. And that's another reason why I'm happy to see biomass sort of, on the same level with biotech, because when we're working with biomass, there's a lot of low-hanging fruit, no pun intended, that can deliver returns to a very dispersed group of interests, both
Yep.
thematically and geographically, economically. And so we need those visible wins in every possible way. And the de-risking plus everything else.
Absolutely. And I think each of you from your respective agency or industry partner, I think has that special role of empowering, rural communities to really take a lead in the bioeconomy here and be that kind of driver of environmental sustainability from their perspective of being the growers of, our food and everything else. So I really appreciate that perspective, Rick, especially from USDA here. And so Matt, I'll let you have the last word. What sort of, things do we need to think about overcoming to kind of make biomass the star of the show?
Yeah, I'm not worthy of this last word, but this is definitely achievable from a supply perspective. And I think like any renewable strategy it comes down to the economics of it and everything that we already talked about on the poll and the innovation to make this thing possible.
Awesome. Thank you. And with that, I'm going to pass it over to my colleague Nazish to get some questions from the audience. Thank you so much for your participation, panelists. This is great.
Yeah, this has been a great webinar so far. I really like all the questions that we've asked and the responses that we've gotten. I think before we go to the audience Q&A questions, I have a burning question as well. And Matt, this might be directed towards you a little bit, but what about the novel biomass that we have? What does that look like? What are our limitations there? What is the brightest star within those novel biomasses that we aren't considering quite yet because they aren't at the readiness level that we need it to be?
Do you mean the energy crops?
Yeah.
Yeah. It's region specific. Just like every crop option, different crops have different yields and costs in different regions. So I don't really have a great answer. Just it's location specific. Biomass is super location driven. So I don't have a great answer, but switchgrass, willow, miscanthus, certainly the intermediate oilseed crops that don't require any additional land pressure and can provide soil conservation, but all these, maybe I would turn a little bit, it's capitalizing on those ecosystem services of these crop options to improve the environmental sustainability of agriculture in different ways. Yeah.
Amazing. And then a lot of our conversation is kind of centered around infrastructure and the biotechnology, and maybe some of the market talks that we've been diving into a little bit too seems to focus on corn. How can we help woody biomass catch up to where the corn perspective is? And this is open for anybody.
So you're talking about utilization of wood, and one of the key areas, so we evaluate technologies across a diverse array of different feedstocks. So by looking at those technologies and matching them up with the feedstocks where they can make the most impact, we then evaluate it techno-economically. And we are seeing a lot of technologies that are enabling us to look at forest residues and woody wastes, which is the starting point, right? If we're able to convert these wastes to fuel economically, efficiently, and build a market, it will enable us then to look more readily at the actual forest and woody resources that we have that are available, which, as Matt said, it's not a huge amount of what we produce in this country, but it is a viable amount. And we can then move into that in a sustainable manner. So I'm not sure I answered your question exactly, but we do have technologies, and the wood lends itself more to those things that won't fall under the biotech definition, like gasification and pyrolysis, where we're, able to take that very recalcitrant biomass and convert it then into an oil or a gaseous intermediate. And from there, we can do all sorts of things.
Mm-hmm. And I think, Tom, maybe you could speak a little bit about the gaseous fermentation side of things.
Absolutely. Yeah. I mean, as Valerie knows well, we would love to have, gasified biomass wastes, and that would be a great application. I will say, from a policy perspective, using woody biomass to make ethanol, for example, which is our product of first resort, even though we want to target that ethanol to higher end uses, if you were going to use that in ground transportation, the RFS is just, an abysmal policy to do that. It is just so difficult because of the tracing and tracking of essentially every piece of wood, which is virtually impossible to do. So I do think we need to update some of our policy mechanisms to recognize that there's a lot of woody biomass potential out there, and Rick certainly talked about it earlier, particularly in forest fire prevention, because again we're trying to go after climate change, and if we can't really incentivize the use of waste biomass, particularly, thinnings and other ways of reducing fire risk, a lot of the efforts that many of us do just go up in smoke literally every year when, forests in the US or Canada burn and just put so much more carbon in the atmosphere than we've all tried to take out, right? So I think we could actually, like a judo move, really move the carbon capture and using biomass as a way to lean into the problem and make it solvable rather than making that hill much harder to climb.
Anything to add there, Rick, as our forester?
Sure. But I mean, the points Tom making are absolutely correct. It really comes down to, the forestry field and the forest products industry for, a century or more, did things that weren't helpful. And that includes the US Forest Service and suppressing fire, but also, clear cuts that people thought were too big, all kinds of angst around how forests are managed. And, I started my career in environmental NGOs, and then we started talking about forestry, and I decided to study forestry, and then I ended up working in forestry for 15 years. And so a key piece of this, well, first of all, woody biomass, well, maybe Matt knows better, or he had a chart, but I don't know if it'll ever catch up to corn. And I don't know if we need it to, but we just want to have as much in the mix as possible from woody biomass. And so some more education and more sort of explanation around why, unintended consequences are unlikely, as the environmental NGOs like to say, whenever we put forward various regulatory streamlining or explanations for why we might need to have a slightly heavier touch. There's always a concern about unintended consequences. So we just need to keep doing that explanation and really positive collaboration with environmental groups that the Forest Service has actually become very good at over the last 20 years in land management planning. There's a lot of strong collaboration there. So we just need to keep that up and keep putting the needle on the measurement and having everybody at the table. So, that way we can get more done in the woods. And also the RFS, woody biomass from public lands is a challenge for RINs. And that's, that's just to pick one narrow issue, but there's some room for improvement there too. So there are policy levers we can look at too. But really it's a lot of education and collaboration to get us to have more woody biomass in the mix.
Yeah, I think that's a really great point there. And I think within the FAS side of things, once we started talking to people, we kind of realized that as well, especially at the regional perspective, that people want to use this woody biomass, but there's a lot of voices in the room that are negative towards it. And this communication and this PRing of this entire problem really needs to occur as a joint effort between all the agencies and all the stakeholders that are a part of this conversation. And then briefly, right before we turn it to audience questions, I did want to touch on the international aspect of all of this. A lot of countries want biomass. They don't have the ability to, or the amounts that we have at the US, and they're kind of looking to the US to see if we're able to provide some of that biomass to them. Do you think that's something that we are going to be able to accomplish in the future? Is this something that we can do at this point in time? Would love to know your thoughts around that.
Well, I will point out that right now, from private forests and wood chipping, the majority of the wood we now grow in this country that's able to be used for biomass is being exported to European markets because of their willingness to pay more and lack of a market in this country. And there are, again, concerns on sustainability and unintended consequences, and we're throwing that biomass over to someone else to actually get the benefits from. So we really do need our markets to be satisfied in order for us to gain the benefits of environmentally from this biomass. And I, want to see us focus there. I would turn.
Oh, I think Valerie froze on us. Oh,
I think he's.
No, you're back.
Did you catch that?
I think we missed the tail end of that. Oh, Valerie's gone again.
Maybe we should move on.
That's okay. Anybody else have any comments around that topic, the international perspective of this all?
I would jump in just really quickly to say that, our perspective is to try to show that the bioeconomy is a distributed manufacturing and a distributed technology opportunity that should be able to be deployed around the world, and those resources will differ, and it won't always be biomass. Some places without great amounts of biomass do have great amounts of sun, for example, so they might be able to produce solar energy and make hydrogen or other things, right? So we first and foremost think that's an issue, and then just material efficiencies as well, and for me, cut back to Valerie's point again of making sure that our markets are fully used and saturated first. I think it gets you a higher, better use of those limited resources, because once you start moving them around the world, you obviously get into the thermodynamics, and you lose energy, you lose efficiency, and sometimes you lose value. And we'd love to take those and take those to value added products as well, by the way. So let's export the value added product, not necessarily the lower level feedstock. More of a personal opinion.
Rick?
I agree with the points raised about satisfying the domestic market as a first priority. And I also agree that, exporting raw material is never a good economic practice. We want to export value added products, if anything. That said, where there like the wood chip market in Europe, where there are opportunities to get a quick win on getting some return, because there's a market for something that we can satisfy for whatever reason. In EU, it's they don't have the abundance of biomass, and they have a lot more restrictions on land use than necessarily we have in some cases. So I think that the export market, so the U.S. can satisfy export markets in biomass, and that plays a role. But we wouldn't want that to be the dominant feature of the bioeconomy, exporting raw biomass or primary processed biomass. But where it earns a buck, let's do it and show people the benefits.
Great, thank you. So for our first question, we're kind of going to be talking about the cost of all of this. We're have been very much using corn as to produce ethanol, and cellulosic ethanol development has been kind of our main bread and butter, but now we're switching over to kind of using more and process captured CO2, but there's a cost associated with it. How are we kind of, working around this, getting around the fact that, using processed and captured CO2 is going to be a little bit more expensive necessarily than using cellulosic ethanol?
If I could jump in just quickly on that, because I think what I hear read into that question is an assumption that all carbon capture is the same, and it's not. And so in particular, I think I'm hearing post-combustion amine-based carbon capture systems. And yes, those are available. Those have been tested. EPA is building those into the new version of the Clean Power Plan, for example. But you don't have to do that in all cases. In particular, let me tell you about this little company called LanzaTech, which takes waste gases as they are. Okay, we don't have to separate them into pure CO2, for example, which is very different than some other processes that are going to require a pure CO2 stream. In fact, we'd love to get carbon monoxide as that's our first gas that we want, because it has both carbon and energy in it. And so you can feed those gases directly through gas fermentation. So that's just the first point. And then everything is on balance, right? That's why we need data. We need to understand what the energy penalties are, what the energy uses are, the CO2 life cycle analysis. That all of that comes out when you run those kinds of scenarios.
Well said. Another question from the audience is, how do we support the build out of filters for blocking point source emissions or gas fermentation technology?
Yeah, I guess I didn't completely understand the question, but I know that we continue to do research and development in a number of different technology spaces. We work closely with our Office of Fossil Energy and Carbon Management, looking at point sources of carbon emissions and how we can utilize those. Anyone else?
I think I answered the gas fermentation part maybe in the previous one. I would probably want some more elaboration on what we mean by filters for point source emissions. That may be getting to the point that when we do capture greenhouse gas emissions and carbon oxides in particular, you do happen to also capture a number of the other air pollutants, criteria pollutants, hazardous air pollutants, and you can deal with those on the front end of a process to remove those, and so that they actually never make it to the atmosphere. And one of my favorite applications of our technology is capturing from industrial flaring that might happen, which essentially creates more air pollution. If we can capture that and feed that through our process, which is a water-based medium within a bioreactor, we can do a lot to actually minimize what would otherwise be direct to the air emissions, depending on what country you're in and what kind of responsive environmental post-combustion technologies have to be incorporated.
Yeah, absolutely. Well, thank you for answering those questions from our audience. I would say if you have any last minute, one sentence points for the webinar today, any final remarks?
Well, I'll just thank you for having us here. I know that Matt's been doing a tour on the billion ton, and I'm excited that we're really able to get people to truly look at the resources that we have, and the billion tons an excellent starting point. And I welcome people to our website for additional roadmaps that answer many of the questions that you guys brought up and others that maybe didn't make it to the list yet.
Yeah, absolutely. Matt, you're on your own Eras tour with the Billion Ton Report, if you will.
That's right.
Awesome. Rick, any points?
And my internet cut out when you started this. What's the question?
Any final remarks?
Thank you for putting this on and helping us all spread the word. I think as murky as bioeconomy is as a concept, the more we're talking about it, but it's these conversations that bring it into context. And
Yep.
Thank you for the focus on biomass.
Absolutely.
That's we like talking about biomass.
Me too. Any last remarks from you, Matt or Tom?
I try to be a dispassionate scientist. I don't know if it comes through, but in all of the above strategy to address climate change goals, obviously bioenergy and the bioeconomy has a key role, some key sectors to play here. And I think we can do it.
Yep.
Thanks for the opportunity.
Absolutely.
One quick note, just of course, thank you to FAS for this and just generally thought leadership and also for bringing scientists to Washington to inform policymakers on Capitol Hill and in the administration on the science, because the science is so important. And